So hello everyone, thanks for joining us today. Thanks Amy for the presentation as well. I'm super happy to be here. This is of course my first time in this meetup, and of course this is not the ideal situation. It would be better to actually be there, to visit your city. Would I would be very excited about that, doing something such a thing in yeah, maybe next time. But for now, we should also say that yeah, in these pandemic situations, there are many things that are not okay, not very cool, but certainly being able to speak at your meetup group from the other side of the world is probably one of the very few nice things in this situation. So I'm coming out from Argentina. So yeah, I work as CTO at Xablu. Xablu is a company that specializes in mobile development in general from the Netherlands, but really a remote first company. And I'm also a Microsoft MVP. Yeah, so I'm here to talk to you about mobile security, which is, yeah, no, I would say it's not really a very popular topic, but certainly it's a very important one. So let's kick this off. Typically, this talk would take me something like an hour and a couple minutes. Let's see if I can accommodate it in yeah, a bit less than that. But certainly, if actually, unfortunately, Matthew can join us, then I might fill in a little bit of his time if it
Yeah.
goes too long, of course.
Yes, I guess we can extend your presentation.
Thank you. All right, so after all, who is this guy? Just to say a little bit of the expectations for this talk, I'm, as mentioned, a mobile developer. I specialize in Xamarin, that's my thing. I actually am one of the maintainers of MvvmCross, even though I'm not super active there at the moment, but I also maintain a library about security. We'll speak about that in a couple of minutes. And I also contribute to open source in general, mostly in the Xamarin space. And certainly, I'm a security enthusiast. I like the topic. I had to work with security in the past, but that is to say that I'm not really a person that works 8 hours a day in security. So I'm on the dev side of things. I have worked with security specialists, and I've learned a lot from them, actually. So I'm just here to know, let's try to figure this out together. That's the way we should position this. So if you have any question, if you have any concern, any advice, or anything that you think I'm missing, jump in, just tune in your mic and let's figure this out together. So let's kick this off. When you look for mobile security in the internet, like in general, you will find a lot of memes like that look like this. So it seems like getting this right is not that easy. And why is that? Well, there are many reasons, certainly. We can name a few. So for example, yeah, first of all, there's a lot of fragmentation in the mobile world. We have different platforms, we have different operating systems, we have older versions that are still alive that we still need to keep. And certainly when you do something for mobile, and especially in a cross-platform framework like Xamarin, you need to be aware that your security is as good as the worst platform that you're taking care of, which means if you're doing an Android and iOS app, well, certainly there are more breaches in Android. And then if you don't do it right for both platforms, then your app can still be compromised. And that's exactly important. That's super important, especially in the mobile world, because we're delivering our source code in the end. So we're distributing our executable files, our mobile apps, certainly, through APKs, APIs. Certainly, users install our apps, and those files contain just the source code. So it's not like a server-side app or server-side piece of software where users actually can get their hands on it. In this case, they do have everything they need and they can go offline and do a lot of different things with it. So this is actually increasing the surface of attack for an attacker quite a lot. In security, you will see that I will mention surface quite a lot, and that stands for how much do you expose yourself to attackers or to be vulnerable. So in a mobile world, we're certainly distributing the entire app. So that is the case, and that makes it tricky. In the end, of course, this is also a cat and mouse kind of game where we will try to do things right, but certainly there's the other side of the table, and that's trying to ruin whatever defenses we're planning for a mobile solution. So we need to be aware that in the end, anything can be defeated. So another thing that you will see that I will mention quite a lot is that we will build layers of security. So in the end, everything in software can be defeated. It's just a matter of time, of effort, and certainly of creativity in some cases, but everything can be defeated. So the best we can do is to add as many layers of security to our apps so that in the end, the person that wants to do something bad will just give up and move on to the next app. That's pretty sad, but that's certainly how it works. So yeah, that's also cost. And then security is not something that you can measure very easily in terms of how much value are you bringing to your organization. So it's not like a feature. It certainly is not as tangible as something the user can do with your app. So in a real world where we have constraints like money, time, and value that we need to provide, well, security in most cases just get discarded. As just mentioned, another side of this coin, we live again in the real world, and people have expectations for mobile teams, and certainly we need to deliver. So I would say it's of course okay that we need to progress, but what's the cost for that? That's something that we need to ask ourselves, and certainly as professionals, as developers, we are in charge there. Our users expect us to do the things right. And in that sense, security, as mentioned, it's not typically a very popular topic at conferences, even at meetups. So it seems like, nobody wants to take the blame. It's like in soccer, I'm from Argentina, so soccer is a big thing here, as you know. And yeah, so the role, this is kind of the role of the goalkeeper. Because if you do it right, then nobody notices your job. But if you do it wrong, well, you're exposed. So that is certainly what happens with security as well. Because it's not that visible or tangible, then it's a bit more difficult to get it right. And for the most of us, we just prefer not to deal with it. So yeah, it's a difficult situation. It's a difficult environment. It's a difficult world. So, okay, so we want to make our apps more secure. So how do we start? And my advice, and this is of course something that can change depending on the context, is to follow OWASP. So OWASP is a non-profit organization that was born in 2001. It stands for Open Web Application Security Project, and it's certainly a very big non-profit that contains a lot of different projects. It's supported by individuals and companies around the world, and they have different standards, different projects. But of course, this can change in your context, because if you are developing for healthcare, there might be some other standards that you are obliged to comply to. So it actually depends. But for a more general aspect, OWASP covers quite a lot of different areas, economical areas. So that's probably the most famous one as well. So how do we do to follow OWASP? Well, they certainly have many different projects, but we will be interested the most in these two. First, the mobile application security verification standard that was kind of, it contains a lot of requirements and guidelines on what your app should do and how it should be built, for example, to be secure. And the nice thing about this is that you can certify your app to OWASP standards. But in the end, this guide only contains how things should be. Now, if you want to, of course, take action there, then you might need to use these other projects as well. They are sister projects, really. So this is a testing guide, but it's not just, it doesn't just contain bullet points on what to test. It actually contains most of the content on how to implement these kind of things. So this guide is supposed to be used by the security experts while verifying that the app is secure, but also by developers to make sure that they are doing it in the recommended way. Now, if you want to also educate yourself, and it's very important to do so while doing these kind of things, they also provide a hacking playground. That's a GitHub open source repository that contains an iOS and an Android app, and a lot of different instructions on how to do something, to hack it, and to fix it. So it's very important also to understand what would an attacker be doing in that case. Now, regarding security in general, you will see that most of the things in this space are open source. So it is, we build this together. And certainly the more transparent we are, the better our defenses will be. So that's generally how it works. So I mentioned that OWASP has different security levels that we can comply to, and they certainly have 3. So there's L1, L2, and Air. L1 is the most basic level that we can get certified. It contains a lot of best practices. It explains you how things should be built. So examples there are that you should use HTTPS, for example, or that you should use the secure storage. But certainly those are things that you can check in a checklist of things that your app does as it is supposed to do. L2 is actually elevating those defenses. You're actually constructing walls there to prevent your app to be attacked in certain ways, but still you're just assuming that if this happens, then my app will be prepared. So for example, my app has its code obfuscated, those kind of things. You're actively doing something to prevent something bad to occur. And then the last level, so Air, that's where you start to play the game of the cat and mouse. So there you would be required to, for example, check if the device is rooted, and if that's the case, then close the app immediately, things like that. So you're proactively fighting the potential attackers at that level. So if your app is a banking app, for example, those kind of things, or if it deals with healthcare, certainly you need to get to that level, but it's not for every kind of app. So what I have planned now is to go deeper and dive into this verification standard one chapter at a time. I have really a lot of content, so I will try to show some examples as well, but just let me know if there's any doubt or if there's any question in general. Chapter 1, it talks about architecture, design, and the threat modeling that the project and the team that works in the mobile app should do in advance. So it mentions, for example, that the mobile security stuff, like in general, the topic is not really just for the mobile team. It also includes all the different remote services that the app consumes. So every API that is being consumed by the mobile app is also part of mobile security. It also says that your app should have a mechanism for enforcing app updates, which is if your app is using an older version and we know that that version is compromised or is not compatible anymore with the newer version that even your backend team has created, then you should have a way for users to notice that they cannot use the app anymore. Now, how do we do that? Well, in Xamarin, we had Xamarin Essentials, and Xamarin Essentials has this small feature that's version tracking. So there you can see what's the current version that the app is using. And for example, you can send that as a header to every remote request that you perform. And then the server could return a special error if that's not compatible anymore, if that version is compromised, whatever. And then you should navigate in your app to a screen that enforces the user to tap on a button and to download the newest version, something like that. But or you can, for example, send a silent push notification to the users. Those are push notifications that do not display banners. And then, well, the same applies whenever the app runs. It should just navigate to the screen where it says, hey, this no longer works. Please download the latest version. It also mentions that you shouldn't hardcode any key, which is something we know. I'm certainly sure everybody knows that hardcoding keys is not okay, but it's mentioned there, of course, and you shouldn't do it really, but because even if you obfuscate your code, your keys are still there. So how do you do that? Well, my advice would be that in the first run of the app, you can use version tracking for that from Xamarin Essentials. Let's actually take a look at it. So I have here Visual Studio for Mac. This is my library actually for security. It's called BreachDetector. It's a multi-targeting and a standard library. But what I want to show you is this part of Xamarin Essentials version tracking. And here you can also detect, for example, if this is the first launch ever for the app. So if that's the case, then what you can do, for example, to get this done right for keys is to download all the keys using HTTPS, of course, from your remote service, and then store those keys locally in the secure storage. And then you don't need to hardcode anything. This chapter also talks a lot about architecture, code quality, and compliance and standardization. It literally mentions that a lot of things that are about, having the team aligned. So it's all about being sure you're talking about the same thing when you refer to it. So it's just to keep the team aligned to move on to the next chapters, so to say. So chapter 2 talks about data storage and privacy. You should store sensitive information in the secure storage. Xamarin Essentials also has an API for that. That's secure storage, the original. So here, instead of same app, same code, Xamarin Essential dot, and here we have secure storage. And then you have two methods. That's get async and set async that you can use to store information. And the nice thing about this secure storage plugin is that it will automatically use key store in the case of Android and keychain in the case of iOS, so it will be safely stored. You're also supposed to enforce a minimum device access security policy when dealing with very important features, like, for example, in a banking app, they will be making a transaction. So this is about making sure that the device, so the phone from the user, has a secure mechanism for unblocking the screen. It should be a PIN code or biometric authentication or password, whatever. But for those kind of features, you need to ensure that the device is actually secure, it's safe. Now, how do you do that? Well, there are certain, this is something that you would do per platform, or you can opt in to use the library I developed. That's, of course, following all the OWASP standards and such. So it's just a library that you can install. It has one method called get device local security type, and it will return an enum, which contains 4 values, and none if it can get it, none if nothing's being used, password or PIN or biometric authentication, and then that should be good to go. Then you're also advised to hide sensitive data when moved to background, and I have an example for that. So this is an iOS and an Android simulators and emulators. I think so. First for iOS, let's go at this example here. This is open source. This is the example, the test app for the same library. So this is something that you would do in your own app. So in the app delegate class, this is at platform level. You would do, when the app goes to background, this method is called, so on resign activation, and you would add just a plain view there. In this case, it's a green color because why not? And then that background will be added whenever, that view will be added whenever you have transitions to background. And then when you're coming back from it, you just remove that view and you're good to go. So let's see this in action. That's the app. And if I move this to background, you see that we have a green area there, so nothing can be seen. Now, why would you care about this? Is because say you're using your banking app again, you're displaying all your banking information, and then you swipe to another app, say Facebook, and you start watching a video, you pass your phone to your friend, and then your friend accidentally just taps on the button that brings all the different apps, and then the banking data would be visible, which is, of course, not ideal. In the case of Android, it's even easier, but it's Android, So this is the main activity class in a typical Xamarin.Forms app, and you would just need to do in your own create method in that activity, Windows set flags, secure, secure, and you're good to go. So let's look at this app here. This is the actual app, the same one. Let me see if this works. I might need. Yes, there it is. So that's the same information we saw before, and if we take it to background, then the information is hidden. But there is a limitation. So what happens is, well, you know, Android is complex by design, I would say. So there are certain limitations to this approach, and there's not much you can do, because what happens is that certain widgets, like for example, the drop-down menu in iOS, it's bringing its own new window on top of the previous window. So if the user has a drop-down menu and then it's open, and with that menu open, it transitions to background, then this would not work, for example. Android being Android. Then this chapter also mentions that you should, in the case of Android, prioritize internal memory storage, and that's because all of the different checks and security policies that Android has for storage in general also only apply to the internal storage. So if you're using a micro SD or something like that, well, any app can read any information that's there, which is kind of very bad. It can get really bad. So in your Android project, in your properties, in the project properties, there's a checkbox that you can mark there to say that your app should be only installed in local storage, in the internal storage. It's highly recommendable to do so. And finally, well, I didn't say this, but everything in storage in mobile apps starts with not storing anything as much as you can. So what by that I mean that the more you store, the bigger your surface of attack will be. So you should only store the least possible, because in the end, it's only a matter of time and effort until someone can figure out that. And in the mobile world, everything is about our users' data. So it's very unlikely that you will have, it could be the case, of course, but it's very unlikely that you will have a very specialized algorithm and piece of IP in your mobile app, but it's very, very likely that you will be handling your users' information in that app. So in most cases, mobile security is all about users. It's all about ensuring you don't make any loss there, and that the data from users is secure. So if you really need to store a lot of information that's sensitive, I highly recommend you to use SQL Cipher. There's a community license for that. Works really great. So on to chapter 3. It's about cryptography, so good old crypto. First, don't rely on symmetric crypto with hard-coded keys, and more important than that, even do not place the keys to that symmetric crypto next to the code that uses it. That's just setting, the cheese and the mouse next to each other. We know what happens when you do that, so don't do it. Yeah, never reuse keys would be the next one. Try to use separate keys for everything, same as with passwords in your own personal life. Store the least possible. We said that before. And just to bring this to a different perspective, cryptography is something that from time to time you need to check, because if you're using old algorithms for crypto, well, that's about the same as using no crypto at all. So it's just a piece of cake for a hacker if you're using all crypto to get this sorted out. So try always to use the latest and greatest. In the case of Xamarin, we have PCL crypto. That's still for PCL, but yeah, most of the still recommended crypto algorithms are working there. So I think it's advisable to use it, at least so far I know. On to chapter 4. We have 8 chapters, by the way, so we're kind of in the middle, maybe. So you should invalidate sessions and expire tokens as much as you can. Again, coming back to this surface of attack perspective, well, you should also consider the time frame for tokens. So the longer the life of a token is, well, the longer or the bigger the time frame for an attacker to do something is as well. So it's all about trying to optimize those little bits And you should also have a logout endpoint in your services so that when the user logs out, then the server acknowledges, and then it's super easy to close that session. You can go and sleep quietly. So yeah, something that sometimes we forget from the mobile perspective is to protect or guard against multiple login attempts. Your backend might be doing it, and if not, well, that's for sure something that should happen. But also in the mobile side, we should take care of it, especially if we are storing hashes for passwords or things like that to be able to log in offline. And about that as well, being able to log in offline brings its own challenges to mobile apps where all the code is delivered to the user. So generally, never store passwords, store hashes if necessary, and certainly be very careful on what do you do with the user password in memory. Try to use hashes in memory as well, because the attacker could actually attach a debugger to your app in many cases, and then they could just have a dump of the memory being used at that time, and then they could gather passwords. And if you want to take this to a next level, of course, this is L2. Some of these points that I have been mentioning are for L1 or L2, so those are the levels from OWASP. This is certainly an L2 one, that you should display the user all the current sessions and allow them to block those sessions on demand. So for example, if their device is stolen, then they can just go there and block those sessions. Actually, I think most social networks have that feature. For example, even WhatsApp Web, WhatsApp Desktop. So it's certainly something that worth the effort for development. Chapter 5 talks about network. It's one of the most important one, even though it's not the largest one. Always use HTTPS. There should be no reason year 2020 to use HTTP. And be very careful with Apple ATS and Android Clear Text. Those are the exceptions that you can set in your project to still use HTTP. So it might be the case that in your development environment or in your staging environment, your certificate expire, or you don't even have a certificate there. So then you would certainly add exceptions to Apple ATS or to Android Clear Text. But be very certain that you remove all those, because if you don't do it, well, things might get complicated very easily. Also consider using certificate pinning. And for that, well, certificate pinning is just a way to ensure that you're talking to the right server. Because one thing is to use a secure channel, which would be HTTPS. But in the end, if you use HTTPS and if you're communicating to the wrong person, well, that's still insecure. So one thing is to use a secure channel. A different thing is to talk to the right endpoint. So certificate pinning is a technique by which you hard code on purpose either the certificate or the public key of that certificate in the mobile app, so that certificate would be the actual certificate from your server, still certified by an authority maybe, but still it worth the effort to pin that certificate. So then whenever you do communicate to that backend, the certificate will be compared, and if it is, then it will proceed. Otherwise, certainly you're not talking to the right guy there. My recommendation for that is to use this library. So for the people that's coming from the real past from Xamarin, do you remember this library called Modern HTTP Client? Have you ever heard of it? Please let me know in the chat window. Open your mic if you will. It used to be pretty famous.
I used to use it all the time back in the day.
Right. So yeah, there's a new one, and that's Modern HTTP Client, like the newer version. It's still open source. It has plenty of downloads in Nugget even. So the thing with this is that preferably we would not use rely on such a library, because it's going to overload a lot of different things that we would in many cases just prefer to go with the defaults. But there's a lot of hassle in Xamarin iOS and in Xamarin Android combined to HTTP client that just make it not work with the defaults. So, for example, in a .NET Core solution, you would do something like this. You would use certificate point manager that server certificate validation callback, and then you would add an event handler that would perform the SSL check. But that doesn't really work in Xamarin iOS nor in Xamarin Android. So yeah, there's no easy way. Also, about that, you know, we have these checkboxes here. I just went to the Android project properties, then Android build, and we have these drop downs, sorry, to say which implementation do we want to use for HTTP client. Absolute recommendation, use the Android client handler in the case of Android and the NS session handler in the case of iOS. That's because that's the only one that you would use TLS 1.2, which is absolutely recommendable nowadays. But I'm not sure if you knew also about this, but if you override, if you create, so the only way that dropdown is going to take action in your mobile app is if you instantiate your HTTP client without any special handler yourself. What I mean by this is that if you do something like this, part client equals to new HTTP client, there it goes. And then we have a client there, and they, of course, you would use it for send, get, whatever. But if the dropdown, whatever you choose in your dropdown, is going to take action only if you use this constructor, or more accurately, if you don't provide your own handler here. If you do such a thing, then you're entirely in charge of your own pipeline on your own stack of the HTTP client. So be aware that if you're providing your own here, then whatever you choose in the dropdown is not going to have any effect. So yeah, do pin your certificate is highly recommendable, but and more than that, even do hard code the public key of that certificate, because that way, when the certificate is renewed, then you don't need to do anything special for your mobile app. It should just work out the box. And then, yeah, always use latest and greatest standards. As we saw, TLS 1.2, that's what you should use. And therefore, you should use native handlers in your HTTP client. So now for platform interaction. First one, if you recall, I said before that it's all about the different components in your solution, and your software is as secure as the least secure piece that is involved. Now, if you do interact with other apps, be aware they could have a breach, and if they do so, well, your app might be compromised as well. So if you're partnered with another company, with another app, and you work together with the other app, be aware their security is your security as well. Something that could happen, for example, say that you have a banking app, and then of course, every month you have a summary of all your transactions, and say that you want to deliver that as a PDF for your users. So, and because you're a banking app and you have plenty of stuff to do, then you don't want to develop your own PDF viewer. You just, you know, throw an intent in the case of Android, an implicit intent, so that the user can opt for what kind of app do they want to pick for that. Well, that's highly insecure, because what could happen is that the user might have downloaded a tampered or insecure PDF viewer application. Tampering is the fact of getting some source code, some executable actually, to change some stuff there and to repack that app and to redeploy that app. That's why, for example, we prefer to only install from secure sources, and why most phones have that option disabled to be able to download apps from anywhere, because you could download an app that's tampered. So coming back to the example, if the user has a tampered app, so an app that is insecure, and they open the PDF from the banking account there, well, the attacker has all the information just for free without even doing much. So certainly be aware that you need to challenge that over time, all the time. And about web views, well, they are highly insecure. So most of these security breaches that we see in the press and things like that regarding web apps are coming either from misuse of platform features. So for example, making a bad use of something that is not, they are not supposed, the developers are not supposed to be using as they are, or from web views as well. So they're highly insecure. My recommendation, please don't use them. Seriously, don't. And because we live in a real world, and we know that in some cases that decision is not up to us. Well, in that case, I would say, okay, it's not too bad. It's not like your app's going to be hacked if you use a web view. It's certainly not that the case. But try to enforce HTTPS. Do not add bridges between your C# and JavaScript code. And if you do so, then be very aware that's very insecure. And as always, try to be very cautious on the timeframes on how much that web view is live. So when the user navigates away from that screen, clean up all the resources so that no malware stays there running. Chapter 7, it's all about code quality, build settings. About code quality, I'm certain we don't need to go through that because all of us are awesome developers. I'm quite sure about that. But there are some things that we can mention. So first of all, try to always remove logs. If the bug is your friend, that will make your app not to output anything to the Android log, for example. There's quite a few cases of apps that got hacked because developers just forgot to remove logs in their release versions, and then by just connecting a wire to your phone, you can see everything that's going there, that's happening. So do not crash. And this is pretty obvious, yes, your app shouldn't crash, but what I mean here is that it's highly insecure, because if your app crashes, your app will write to it will dump a lot of information, and that can get insecure. So if a hacker actually detects that the app crashes, they will try, for example, to do as many actions as possible and then make the app crash at the end and see what happens, what's the output for that crash log. So certainly that can get really tricky. So if a hacker gets their hands into a crash, there are many things they can do. Regarding build settings, AOT is quite all right. It's quite awesome. On Android, we can opt in for AOT, but that doesn't mean your app will be secure. So AOT, for those who don't know, will provide binary versions of your DLLs so that the app runs faster and starts faster, certainly. So it's not going to use GIT. Yes, but still it would include those DLLs. So if you get your hands into Xamarin app to an APK file, you can extract, you can rename that as a zip, unzip it, and you will see DLLs. And if you're using AOT, then you will see those .so binary libraries for an IoT kind of app, but still DLLs will be there. So it doesn't mean your app will be secure because it will compile to bytecode. But certainly there's another option in Xamarin that's an enterprise kind of option, which makes it less accessible to everyone, and you should definitely make use of it. So there's a checkbox in your project solution, in your project property, sorry. I'm back to Visual Studio. Let me go to the project properties here, Android build, and there's this option to embed assemblies in native code. This, so far I understand, an enterprise kind of tool, kind of option. Now the cool thing about this is that if you do so, what Xamarin will do is to embed all of your DLLs, zip them, and embed them into a .so binary, which is a little bit of an obfuscation that you get there. But more importantly, that makes your DLLs harder to tamper. So if there's an attacker that wants to tamper your app, then they could just modify a DLL, repack it, and do some more stuff and good to go. But if you're using that option, then they also need to go through the process of, you know, compressing that and making it .so, which is a bit harder. So you should use it if you can. And one more, use debuggable false. As I mentioned before, you can attach a debugger to an app. It's as easy as that. And this is absolutely for Android, of course. So there's a very easy flag that you can set, a very small flag that you can set in your Android project. It's about an assembly attribute. So for if your version is for debugging, then you can opt in for that. Of course, you want to debug your app in debug mode, but for release mode, just set it to false. Now, of course, this can be changed, and this, of course, if an attacker knows what he or she is doing, this is very easy to do. But still, security, as mentioned, is all about adding layers on top of layers on top of layers and making really an onion of your app in terms of security so that the attackers just give up. So, and that takes me to chapter 8, which is the last chapter. And I think I've been doing, yeah, I did it quite fast, honestly, so we might get extra time even. So resilience. This, oh, by the way, this entire chapter only applies to the last one. So the chapter air, sorry, to level air. That's the highest you can get with OWASP, okay? So your app should be able to detect jailbreak through debugging and emulation conditions. There should be no reason for a user to be using an emulator or to, you know, be debugging your app at all. So if that condition applies, your app should close itself or, you know, do something with that. But it should certainly detect that condition. And now for jailbroken devices or for rooted devices, there are certainly a lot of things that a user can do with your app there. So for example, if your Android device is rooted, then all the permissions, staff, and policies for the storage don't apply, or users can just extract everything. So you shouldn't allow users to run your app in such scenarios. Now, how do you do that in Xamarin? Well, again, coming back to my library, and I say my library, but honestly, I don't take any credits there because what I did was to grab the most successful projects for security in the traditional Android and traditional iOS worlds. And I just make bindable libraries for them, brought them to Xamarin, and expose a very simple API that we can use in a cross-platform manner. So you can see here, so this is called BreachDetector. And for dependencies, we have in the case of iOS, one dependency only, but in the case of Android, we see that we have 3. So that's all I did, and the code is real simple. And I honestly advise you to check it out. It's really simple, and let's do this together. If you find any issue, I'm super happy to get any contributions as well. So this library also exposes a few methods that are useful in this case to detect, to say, for example, if the device is rooted, if the app is running on a virtual device, or if it's being debugged, or if it's installed from store. Now, why would you check if the device, if the app store is installed from a famous store like Google Play or the Amazon App Store or the Apple App Store? Well, because you can prevent that way that the app is not being tampered. If the app was tampered, it certainly didn't come from one of the stores. So therefore, you can close the app or do something there as well. Now, for the checks, what this is doing internally is performing a lot of different things. Certainly, I'm learning about that myself, but for most code that you will find there, I didn't write it. I just, these are libraries that are, of course, license friendly, and I'm just adding and aggregating all that code to perform those checks. Again, security is all about adding layers and not about making it something impossible to do. That's not how software works. So all of these checks can be defeated at a certain point. But if you're doing things right, then even if these checks are defeated, the attacker would not make advantage of anything in your app because you have other layers to secure that. So if you want to get this certification, you also need to detect reverse engineering conditions. So that's, for example, there are a lot of tools like Frida that are there to perform reverse engineering stuff, and your app should detect if Frida is running, for example, side by side to your app, and if that happens, then your app should close. Your app should also detect tampering conditions. We talked about that for a bit, and you're highly recommended to obfuscate your code. Now, in the .NET space, we have a very famous project. It's a company actually. It's called .Fuscator. They have a community license. It's installed by default with Visual Studio. Highly recommendable. Obfuscating your code doesn't mean that your app is not going to get hacked or anything like that, but certainly it adds quite a nice layer of security to it. So I think that's all I got. Now, for my conclusion, I would say follow OWASP, and that you don't really need to be an expert to get this right. I can speak for myself. As mentioned, I'm not a guy that works 8 hours a day in security, but I'm just an enthusiast, and I started to read the guides from OWASP that are not so long, and they are quite entertaining as well. So yeah, that's the path I followed, and what I recommend you to do as well. So more important than anything else, you really owe this to your users. They don't have a clue of what's going on there, and yeah, they use your apps, they trust you, and they provide you with their data, and they just think you're doing it right. So we really owe this to them. So that's all I got. I don't know, Damien, if we have any questions or if anyone wants to open their mic. But from my side, thanks a lot, really.
Thank you, Nico. I have one question, actually. You showed a method from BreachDetector plugin, the method which detects if application is installed from store. So my question is, does this method support detecting if application was installed from Huawei App Gallery?
Let's check that. Actually, this is open source entirely. So in the case of Android, it's not there. Yeah. We should actually add it. So it's Samsung app is there, but certainly Huawei, sorry, that one you mentioned is not. Happy to take a pull request, or if you can write that in the chat window, I can add it. But will be maybe a nice opportunity to open a pull request there.
Yeah, I'm asking because recently in our project we are, investigating this app gallery from Huawei.
Nice. Yeah, yeah.
So, are there any questions for Nico?
I actually have 2 more slides. So this is not really related to security, but maybe in the meantime, people can think about questions. So I also work as CDO at Xablu, and we have a very special gift for you for this opportunity, for allowing me, of course, to be here. So this is something that we're pretty fanatic about Xamarin. Let me put it that way. So we have a service that's support for teams, basically. So if your team is stuck developing any feature or anything at all with your Xamarin app, or maybe if you're not really reaching your 5 stars review in your app, or if you just need an expert code review on some architectural things, or if you're just blocked because you don't know how to deal with some breaking changes in your NuGet apps, in your NuGet dependencies, or things like that, then we're the firefighters of in this mobile world. I would like to call ourselves like that. So yeah, everyone gets a free hour support from Xablu. I will paste a link to that in the chat window. So certainly we want your problems, bring them in. This is absolutely for free, nothing to be scared about there. Just, we really want to know what are you building with Xamarin. So just go make use of it. I'll drop the link in the chat window. Here it goes. Right.
Yeah, it's so quiet. No questions, really.
So do you guys know about OWASP before? How new is this for all of you?
There is one question actually from the chat. So the question is how to disable extracting core code from APK file.
Well, from Xamarin, there's not much you can do there for your DLLs. So you should obfuscate your code if you want to get that difficult for hackers, and you should also use the embedded assemblage insanity code checkbox. And if there's anything else, well, certainly not something that the platform provides. You would need to go for security pay solutions to check if they have something for that for you. So generally in the Swift space or the Kotlin space, there are some companies that provide this kind of service to really make it not hard, but super hard to hackers to get your code, but not something that we get out of the box with the tooling. And that actually brings me to something I forgot to mention, not really related to Xamarin, but generally about security. Never trust a platform. Never trust HTTPS. Never trust anything. Everything can get defeated. Even HTTPS, there are many scenarios. So if the user is using that very crowded Starbucks Wi-Fi, whatever could happen there, those kind of networks are easy to tamper. So don't rely on believing that what you use is doing all right. Don't rely on things like that. If you want to add an extra layer of cryptography on top of your communication through HTTPS, it is advisable to do so. Same about the storing information in the secure storage. Do encrypt that with your own crypto. Never trust any platform at all. That's general security advice.
Yeah, it's better be safe than sorry.
Yes, it's all about that, honestly. Yeah.
We have another question. The question is there an organization for certifying your app?
Yes, so OWASP is they can do it certainly. I don't know how pricing works there. OWASP is non-profit, but they had a lot of full-time people, of course, working at the organization. But you can certify your app there. And this guy, everything we saw is about that, how to, some advice on how to get that certified. That's how hacker work. Well, not quite. So there's I'm in touch actually with a company that specializes in security. So generally, how this works is that security should be a day-to-day topic, should be relevant like any other topic for any software development team. In many cases, that's not the case. So that's not how reality works. So what I've seen the most is that security is somehow comparable to QA. So very large organizations typically have their development teams, handing over their code to QA or to security, and it's just one more step in the pipeline to get that out. And there are many companies that specialize in security and work as security departments for other companies.
All right, guys, are there any other questions? So I guess there are no other questions. I think we can slowly end the meeting. So Nico, that was a great presentation with a lot of useful knowledge. I made some notes and I know what I will be doing tomorrow in my project. I will be improving security of my application. So thank you for your presentation.
Yeah,
And
please. Actually, thank you for having me, for allowing me to present this. So I'm super happy about that. Thank you.
Always a pleasure. And I hope maybe in the future we will, meet in person instead of online meeting. I'm
Yeah, that'd
looking
be
forward
great,
to that.
actually. Yeah.
Yeah. So Nico, thank you once again, and thank you all of you who has joined us today. And I hope we also see at another meeting of Xamarin Warsaw mobile developers. So thank you and take care. Bye bye.
Thank you, everyone. Bye.